Welcome back, guys. In this video tutorial we'll be starting to talk about the problems regarding uh, volume and area, which are related to geometrical problems. And these are the type of problems that you're going to witness more in the competitive exams. Majorly in this video we'll be talking about the formulas and tips that we require to solve those kind of problems, because these are geometry and we need to look for formulas, right? So let's look for formulas to solve those problems. Now there are different geometrical shapes and different formulas are there for different shapes. So let's begin with those different formulas. Now let's first begin with cuboidal. So cuboidal shape. Now we need to draw those shape first for getting the understanding. Now if I draw the cuboidal shape, how it will look like? It will look something like this. So here we go. It will just look like this, and another will look like this, and it will be joined together to get this. This is a cuboid. So this is a cuboidal shape, and let's now look for formulas for the cuboidal shape. So formula for volume. So let me write the formulas here. Formulas for volume. Formulas for volume in this case simply is for knowing volume, surface area. So let me first write surface area SA, and we will looking at the diagonals. We require all of them. So we'll be looking for the formulas here. Now here what we can see in this kind of problems that the length here, this is the length and this is L, small l. And if we look at this is height, so it is I, and this small length is B. This is B, and the height is that distance. This is going to be the height, and this distance is going to be B. So we get three of the important terms: LB, and this is H, height or H. So you get three important variables here in this case, three parameters. So the volume in this case obviously is simply length multiplied by this small b multiplied by the height, which is length, breadth into height. We get the volume, and volume obviously is in cubic units. So unit to the power cube. Okay, whatever unit, it's a centimeter, so centimeter power cube and whatever. Now surface area for this, and to calculate surface area we have, surface area means we have one side here, another side there, these two sides, so two sides each, two side for this, two side for this and that, two side for this and this, and for so on, right? So look for the sides. We just take 2 multiplied by L into B multiplied by B into H multiplied by L into H, and this will be in the square unit. So unit to the power square will be the unit in this case. Okay, now look for diagonals. And what are the diagonals? You all know diagonals means one starting from here ending up there, starting from there ending up here. So these are the diagonals. So diagonal here will be something different formula, like L square plus B square plus H square, and square root of this L square plus B square plus H square, and this will be in simple unit terms, right? So this is for the cuboidal type of shape. Now if we look at the shape of cube, look for shape of cube, how it will look like. It will look something like this. So now let's draw cube. Cube will be just like this. It's a perfect square, remind you. Then rest of the part will just look like the previous cuboidal, like so. This will look something like that. I have some mistakes of drawing there. So this is how a cube look like, and the formulas for cube are much more simpler, because all of these lengths, this L, this B, this H, everything is same in this cube. So if you imagine this as a cuboidal, you simply get L equals to B equals to H. So everything is same, and we just keep it as A. We just take example of all these things as A. So what will be the formula here? So the formula, remember, for volume, equals to, here it will be all the sides, right? So A into A, or simply I can write A cube, and unit will be unit cube. Let me take it. Yeah. So A cube is going to be the formula. Now if we take the formula for surface area, and the formula for surface area in this case will be again, 6 surfaces are there, and the surface area for each surface will be A square. So into 6 surface, so 6A square is going to be the surface area, and this will be unit square. And the third thing is the diagonal value, and diagonal will be in this case root 3 into A. Root 3 into A is going to be the diagonal. So this is the formulas for cube. Now let's scroll it down, and now let's talk about cylinder. For cylinder, how cylinder is looking like? Cylinder will look like something like this. So it's obviously a hollow cylinder. So let's draw the pipeline first. Then, so it's a hollow cylinder like that. So if this is the cylinder, it will look like. And in this case, we know from the center there is a spherical surface in both. There's a circle in both the ends, and then a straight line. So the straight line here is termed as H. This total length termed as H, and this distance is termed as R from the center. So if you know this thing, rest of the things are easy. So the volume in this case, volume for the cylinder equals to the formula. So let's write the formula. Formula for volume is simply pi r square. It's the volume, it's the surface area for the circle, into h, which is the length. So the volume is pi r square h. Now if we look at the surface area, the curved surface area and the total surface area, if we look at the surface area curved, this curved surface area, we get the value of, let's put the value of 2 pi r h. This is the square units, so unit square. And if we look at the surface area total, because that is required most of the time, total surface area, it will be 2 pi r h plus r, again unit square, right? So this is the total surface area. How these formulas actually came, you need to look for more mathematical backgrounds. I don't encourage you to do that. Just memorize these formulas, because it will be required for your future studies. Okay. Now if we talk about cones. So how a cone is looking like? Cone will look something like this, right? Like a cornetto, much like. So it's a center, and if I draw a line from center like this, and this distance is simply termed as r, remember, and this whole distance is looking as h. This complete distance is h. Okay. So this is h and this is r. So again, what are the different formulas for cone? So let's put the formulas here. Let's put it. Now let's take this one. Let's say, so if we look at the volume for a cone will be 1/3 pi r square h. This is the volume, and unit q will be the unit for that. Okay. And the surface area, again, two types of surface area. It is one for curved and surface area one for total. So surface area for curved here will be pi r l, and surface area total will be pi r l plus pi r square. Both of them will be unit square, right? And if we want to know the slant height, this complete height, or L, the slant height will be h square plus r square, and root over of h square plus r square. So this is going to give us the slant height, or slant height means this is the height, and it is, remind you, required. This is called L, or slant height, and it is required in many mathematical problems. So you need to remember how to get this slant height. So let me write it here. This term is slant height. Okay, that's it. So it's about cone now. Okay, so once you understand this four, and what we remained in the last part is sphere and hemisphere. So don't need to talk about hemisphere much, but sphere we need to talk about. So let's talk about sphere. Let's talk about sphere here. So for sphere, this process is very much simple, because for sphere is nothing but a simple surface like this. It's not actually sphere. So let's try to draw a circle here. It's kind of, so it's kind of circle like that. And in this case, for this case, if it's a volume, it's not two-dimensional. Remind you, this is a 3D structure. So volume for that is simply 2 by 3 pi r cube and unit cube. This is the volume for a sphere, and surface area for curved line, it will be 2 pi or pi square r, and for surface area total it will be 3 pi square r. Okay, these are the different things. And one thing you should know about all of these spheres and calculations, and that calculation is 1000 cubic centimeter equals to 1 liter, and that is required for most of your problems that we are going to solve. 1000 cubic centimeter equals to 1 liter, and that's for sure. Okay, so that's the thing. And in this case, this r means this distance from any place. This is the r. Okay, and this complete distance is obviously 2r, that we all know, right? So these are the different formulas that we need to learn for cuboid, cube, cylinder, cones and sphere. Once you know these formulas, it will be easy for you to solve the questions that we are going to solve now. Okay, so that's it guys, and I hope that's helpful. Thank you.